Hi class, let's finish up these story problems on parabolas. So here's problem number 3 on our notes for today, which is 6.8 notes day 2. So this problem number 3 says the height of a punted football can be modeled by the function h of x equals a negative 4.9x squared plus 20x plus 1, where the height of the football is h of x is given in meters. So keep in mind this time it's not in feet, it's in meters, and the time x is still in seconds. So as you guys all know, when a football is punted, what type of a shape does that look like? It is, once again, a parabola. So what I want you guys to do is I want you to try letter A all on your own. What is the maximum height of the football? So pause the video, try to do that one using your graphing calculator. After doing this one, what you should have got is hopefully something that looks a little bit like this. I set my window where the x minimum is a negative 5 and x maximum is a positive 5. So x min is a negative 5, x max is a positive 5. And I set my y minimum at a negative 10 and my y maximum at a positive 25. So once I set my window with those values, I ended up getting this picture right here. And then when it says what is the maximum height, I did second calc because I wanted to calculate that maximum value. And that maximum value is 2.04 seconds at 21.4 meters. So after 2 seconds, I'm just making sure I get this right, when x is in seconds, so after 2 seconds approximately, my football, which is in meters, is 21 meters up in the air. So what is the maximum height of the football? It is 21.41 meters. And as you all know, the higher a football is punted, the better off you are for your team because you now have better coverage going down the field to get the tackle and so on and so forth. So the higher the football can go, the better. So hopefully you got that one on your own. Hopefully that wasn't too much trouble for you. Letter B is a tricky one. At what time in its flight is the football within 5 meters of the ground? At what time in its flight is the football within 5 meters of the ground? So class, look at our graph right here. Our y-axis is in meters. So if this is approximately 21 meters, right? Half of that would be 10 meters, so this is about 10, right? And we want to know when is it approximately 5 meters. So how long is it from here to here? At what time in its flight is the football within 5 meters? So what time is this, where this comes together? And here's approximately 5 meters. At what time is this? So here's what I want you to think of for a second, class. Our equation, which is right here. I'm going to copy that down again. So that equation of 4.9 x squared plus 20x plus 1. This function describes the height of the football. So what do I want? I want when is this function less than 5 meters? Okay, my height, my h, is all by itself on this side, which would be the same thing if I were to put it on this side. When is this equal to h of x? Or when is this greater than a height, or less than, either one, of a height of, we're going to say, 5 meters. So if I want to say at what time in its flight is the football within 5 meters, I want to know when is it less than 5 meters of the ground. So now, class, if I were to solve this inequality by putting a 0 on the right side here, I would then have to subtract 5, correct? Subtract 5, subtract 5. So my new equation is 4.9 x squared plus 20x minus 4. Less than, or I guess we could say equal to 0. Okay, so now here's what's going to happen in your graph. When you put this in your graphing calculator, right now it's right here. Or right now the x-axis is obviously where it states. But when you change this, so when you're going to put this value into your graphing calculator, what's going to happen is your whole graph is going to shift down. So now this green line is going to be your x-axis. And once you do that, if you find where the 0 is right here, and you find where the 0 is right here, you found that the time at which when the football is within 5 meters of the ground. So what we're going to do here is let's put this part in our graphing calculators. Y equals 4.9 x squared plus 20x minus 4. So go to your graphing calculators. Y equals, instead of this positive 1 over here, put in a negative 4 minus 4. And now we graph it. So we get a very similar function. The only thing that happened is that our parabola dropped down 5 units, or 5 meters. Okay? So now when it says, at what time in its flight is the football within 5 meters of the ground? Now, class, all we need to do is find this 0 and find this 0. Because we've already rigged it in our equation to make it work that way. So now all we have to do is we go second calc, and what I want to find here is I want to find a 0 of the function. So go to number 2. We want to find that 0, so left bound, right there is left bound. Now go right bound, right approximately right there. Guess, let's put it right on it as close as we can. At 0.21 seconds, my y is 0. At 0.21 seconds. So that's going to be one of my answers. At 0.21 seconds. 0.21 seconds. My other 0 is going to be way off onto the right. So my first 0 was on the left, my second 0 is on the right. I calculated my 0 in the exact same way. This time, my 0 is at 3.87. 3.87 seconds. So what happens, class, is my football is punted. After 2.1 seconds, okay, so right in here, that's when it's beneath my 5 meters. Now I changed my graph down 5 units, so that's why it's at that 0. So it's less than 5 meters for the first 0.21 seconds, and then it goes up in the air, up in the air, up in the air, and now it reaches 5 meters, and now it's less than it again. And when is it less than 5 meters? When it's 3.87 seconds and everything after that. So your answer, the ball will be within 5 meters of the ground for the first 2.1 seconds and after 3.87 seconds.